Maybe now it'll work. Yep, there we go. These are mainly linear functions. All right, so when I usually introduce this, I kind of talk about just a simple little application thing where I talk about a plumber and they come to the house and you got a plumbing problem and they're going to charge you money, that kind of thing. So I usually put time here. Some of you have already seen this. And money. Okay, 0, 1, 2, 3, 4. All right, and the idea is that when they walk up, just to your house, say that's $40 or something like that, and then let's say they charge, we'll keep it simple, like 50 per hour or something like that, because they're kind of expensive. So when they first come up there, it's 40, right? So I put that there, and then they go down and they analyze the problem, and so it's 40, and then we get 50 because they were there an hour. And so then this becomes 140, and pretty soon it just keeps going. And oh man, all this money, right? Okay. But the thing is with a function, okay, it has to be so that this time can only be associated with one value. So if you have a 10-hour job, they're only going to charge you one rate. Okay, so that's the idea of a function. So there are actually, let's back up just a second. There's actually two things in mathematics. There's what is called a relation, which is just a correspondence between two quantities like that one. Okay, so there's just this correspondence between two things. All right, but a function is a special relation. So a function is a relation for which there is only one quantity paired with one quantity in the domain, which might not make sense right now, but will in a little bit, paired with one quantity in the yeah, I kind of like that, but not a whole lot. So basically we got some stuff here. So we have domain, we have range, all right? And the domain of a function is called the input, or the x, and the range is called the output, or y. Okay? So the plumber deal works because the time is the input. Okay, so that's my domain. And the dollar is the output, which is the range. And that's why that works. But there's a number of functions. I mean, there's different functions out there that can be related besides this. Okay. So really, I probably should have said for each quantity in the domain, there's one quantity in the range. All right. So again, they can't charge you two different amounts for 10 hours. You know, they just can't do that. That doesn't make any sense. So that's why that's a function. Okay. Domain is input, range is output. So in your textbook, they have stuff like this, where they draw like little eggs, okay, round things like this, and they put numbers in here, and they put numbers over here, and then they draw arrows, meaning that 1 is associated with 8, 2 is associated with 9, 3 is associated with 10, 4 is associated with 11, and they say, hey, there's a diagram, that's a function. Okay? Cool. So if we wrote this as an ordered pair, we would write it as 1, 8, 2, 9, 3, 10, and 4, 11. Okay? This would be your domain here. And this would be the range here. That's how it works. I don't know. There's probably a formula. Yeah, there is. There's a formula relating those. Okay? But that's not what they're talking about right now. And again, this is a lot. If you took Math 65, I don't know if you did. And if you did, this is exactly the last thing you did on that section that was in there. I can't remember what it's called, but that was it. So then we do another one here. And they might go like this. Okay. Domain, range, ordered pairs. Still a function. 4 goes to 12, 1 goes to 14, 2 goes to 18, 3 goes to 20. Still a function. Let's draw one that's not. Let's not make it too confusing here. Okay, this one's not, because 1 goes to 8, but it also goes down here to 64. And that makes it not a function. Okay? Because it goes to two things. You can't have that. So that's not. As soon as you see a domain number going to two different things, then that makes it not a function. All right? Now it is okay. We could draw these all day. To have this. Okay? So every single one of them is 10, kind of boring, but that's okay. Because still, this is just going to 1, this is still going to 1. They're all going to a number, not 2. All right? Even though it's the same number, that's okay. Okay, so here's kind of an interesting one without even numbers. So if we have people, person A, B, C, D, all right, and we have phone numbers over here, well, this person could easily have two numbers. Maybe they have a cell phone number and maybe they have a home number. Okay? So is that a function? No. Because it's going to two different things. Okay? Doesn't work out. It's not a function. Okay? Another one would be, I was thinking about this morning. Call it like a well, we'll just call it people here right now instead of a residence. And zip codes. A, B, C, D. Now it's possible for each one of these, they all have the same zip code. Is that a function?
Yes.
Yeah, it's okay as long as, you know, they all have the same one, but they're just one-to-one. Okay? You're not going to have two zip codes. Confuse up the mail people, right? They wouldn't know where to deliver your mail. Okay? So, those are things that are, those are what functions kind of look like. And we spend a number of, well, we spend quite a bit of amount of time talking about functions in here. And if you're going to go on to more math classes, you're going to do more functions and more functions. And if you go all the way to, you know, calculus or whatever, if you get that, if you want to do that, then you would just strictly talk about functions. You don't even talk about much algebraic stuff anymore. Okay, it's all about functions. So it's good if you have a pretty good idea conceptually of what those things are. All right. I'm really kind of beat that a lot. So let's do this. I want to give you some things that, well, what am I going to have to do with this stuff? Okay, so what about, for example, what is it they're going to ask you to do? Okay. One of the things they're going to have to ask you to do is evaluate them. Okay. So how do you evaluate them? Well, first of all, here's how they're named. So you'll see something like a f parentheses x, which we say f of x, equals 3x minus 2, we'll say. Or we can have something with a g of x. F, g, and h are the most common things, but they can use any name. Okay, 2x squared minus x. We could have h of x. These are the most common ones. Square root of 2x, something like that. Okay, so these are all different types of examples. And evaluating would be to say, okay, I want to figure out what f of 4 is. All right, I want to figure out what g of negative 2 is. I want to figure out what h of 10 is. Okay, so then all you have to do is put this number wherever you see an x. Because basically what's happened is you've replaced this x here with this number. So you're just saying, hey, I'm just going to put that in there, right? So you would use your calculator if you want to. This one I don't need to. 3 times 4, 12 minus 2 is 10, so I'll put 10 there. Negative 2, you got to square that. So negative 2 squared I know is 4, times 2 is 8, plus 2, so that's going to be 10. And then this one would be a square root of 20, wherever the heck that is. I'm just going to put square root of 20 down here. Okay? That's all you have to do for evaluating. It's really simple. You just put the number in there and figure it out. Okay? Very simple for evaluating. All right. Then they're going to ask you to, let's see, write each function as a set of ordered pairs. Give the domain and range. Okay. Domain, range, and here's kind of what they do. F of 2 equals 8. F of 3 equals 17, and f of 4 equals 0. Some crazy thing like that. Okay, so the order, this again, this is x, right? X, x. So then I would go 2, 8, that's my ordered pair. 3, 17, that's my ordered pair. 4, 0, that's my ordered pair. Domain, domain is x. 2, 3, 4. Put little squiggly brackets around it. range 8, 17, 0. All right? That's all there is to that. Okay? So, questions on anything we did there? There's a lot of stuff in 20 minutes, I guess. Remember, ask questions if you have it. If you want me to slow down or something, say something. We're pretty relaxed here. Yeah, just say stuff. All right. Not done yet. Not done yet. They want us to sketch some graphs. Okay? I think so. Anyway. Let me double check here, see exactly what I had you do. Yeah. All right. This would be a perfect time to take a look at Desmos a little bit, I think. All right. Okay. So, unfortunately, I can't pull that up on the tablet because I can't access the internet here. Don't know why. Just never been able to do it. So I have to go back into, let's see, this, and pull it this way. Nope, I don't want that. I don't know where that's on. Oh, that's what I want right there, I think. No. I want that off. No, I don't want that. Why is it? This is weird. Oops, I pushed the wrong button that time. Got to disconnect it. This is really strange. I fixed it. All right. So, if you go onto your, if you just go and Google DESMOS, okay? DESMOS. You'll get a graphing calculator, and that's what it looks like. Okay, sort of, at least from your mobile device, kind of looks like that. Again, you can download the app if you want to. I've never done it. All right, I just go right to the just use the online version. Okay, but you certainly can do the app if you want. Okay, again, this is free. This is great stuff. All right, you'll end up liking this. Not only is it graph things, but it's also a calculator. So if you just start typing stuff in, all right, it figures it out for you. Okay, it's really nice. All right, so up here where this little plus is where you would add things. Okay, so an expression, a table. Okay, you can even put a picture in here, or you can put all kinds of stuff. All right, so if I want to graph something, even though it says f of x, it's not going to like that too much. You can just put y equals, because f of x and y are the same thing, and we'll just put a line in here. Okay, and there it is. It graphs it for you. All right, you can put anything that you want, and it will graph it for you. Okay, it uses nice colors. All right, you can zoom in and out, whatever you want, and it's kind of nice because all I have to do is tap, and it will give me that point, okay, where they cross, and I tap, and it'll give me that point. Okay, I can look at these points. So if you just use your finger and tap, it's great stuff. All right. So that's how it works. All right. Let's get rid of these guys. What I want to do is talk about this. Y equals 1/2 x plus 5. Oops, but not like that. There we go. No, I don't want the x down there, dang it. There's where I want it. Okay. Nice, simple little line. Slope is 1/2. You probably know that. Y-intercept is 5. Okay. So what I'm going to do is just start on this. Okay. So there's my negative 9.36, right? And as I move across this line, all right, every x is paired with 1y. Would everybody agree with that? All right. Every x is paired with 1y. So this is a function. Okay. It doesn't matter. I can keep going. I mean, I can do this all day again. But every x has 1y. So we say that's a function. All right, you can do the same thing. Just take your finger and run it around there, and it will do it. Same thing. Okay. Let's do this. Y equals 2x squared minus 8. All right. Same thing here. Let me get rid of this. All right. Again, every x has 1y. So we say that's a function. All right? But as soon as I come down here and put in something like this, what the heck is this thing? Okay, here's the deal though. Because even though I'm down here, let's say at -1, if I can get close to -1, right there, almost. I can't, there's -1, pretty close. Okay, it's -2.5 here, but also up here, -1 is positive 2.45. So, is this a function? No, because it's two values. Okay, so that's not a function. All right, so there's a way to tell that graphically, and it's called the vertical line test, right? And you learn that again in 65. So if you take a vertical line like this thing, and you pass it through there, and it touches in more than one spot, then that makes it not a function. Okay, makes it not a function. And they talk about that in here, the vertical line test. They also talk about, there's so much stuff in here. They also have, say, a graph. Let me get rid of this one because I don't want this on here anymore. They give you a graph and they say to evaluate this function at some point. All right, so let's say we want to know what it is at f of 3. All right, so then you come over here to 3. All right, I'm obviously going to go down. It's going to go over and down, and right there is the number I'm after. Okay, and I think if I put 3, no, that didn't work too well. I just added it, made it 43. No, I thought I could put 3 in there, but anyway, so I estimate that, and it says it's about -2. Okay, so if you want to know what a certain graph is, so if you go to 3, we get -2. If you want to know what it is at 5, we go down here to 5, we get -6. If we go over here to 1, we would get 2. All right, so they're going to give you some graphs, and you just got to figure out what the y value is. All right. The other thing that's kind of tough to do, okay, and that is to find domains of certain functions. Okay, that is kind of difficult to do. So, first of all, the domain, and I'll try to write all this down on a tablet too. The domain of this. So, domain is really hard to from a graph point, is kind of hard to explain. All right, I wish I had a good way to do it, but basically, if I took this line, all right, and domain is x, so that's here, right, and I folded it down, or I turned it down this way, or I thought about going like this, okay, I would cover everything on that x-axis. So then the domain would be all real numbers. That's what we would say. All right, because that line covers everything on the x-axis. Okay, so that's going to be all real numbers. Same with the range, because this line would cover everything on the y-axis. If we took it and brought it this way, or thought about running a whole bunch of horizontal lines across, it would cover everything on the y-axis. So we say the domain and the range are all real numbers. Let me get rid of this guy.
So what's the proper way to notate domain range? Like how you actually write it out? Just like this?
Yeah, that's how I, now, so let's do this, right? So if we have a line, okay, let me draw the line in red. All right, so then we would say the domain of this would be all real numbers. Now, you can write out all reals like this, or you can do what is called the double bar R. That means all real numbers also. Okay. If we had the parabola one like this, okay, domain is all real numbers. So I could do this, okay. Range would be y, because range is y greater than or equal to -4 if I make this -4. Okay, that's how you can do it.
Thank you.
Any questions on any of that? Okay. There's a lot of stuff in there, so why don't you go ahead, take about 5 minutes, all right, or a little more if you want, and kind of take a break or get some water or do whatever you want to do. And then we'll cover 2, 1, 2, 3. And then I'll give you some time to work on some stuff.
Yeah. Bookstore here.
Well, you know, let's see what we can do here, Josh. Come on over here. Come on. I just want to make sure that you're getting. So usually, what happens is when a student adds, I have to go through and allow you to do that. But did they say anything about that to you?
Well, I think I just go to, and I think they have to do that. I'm not sure.
Yeah, that's how they used to do it.
See, I take it as an audit. Just as that.
All right.
I'll just go, we'll know by next week.
If that's what I mean, I'll do whatever you want to do.
I didn't know what.
If you want to wait, it doesn't
I
matter.
don't know if you can have me.
I can add you.
Oh, okay.
Yeah. I just got to get to the right thing.
And then can we buy a used book, or is any of our stuff done online? You know how you have to have those numbers sometimes and work online with like the
I know what you're talking about, but I'm not sure, to be honest with you.
Should we buy a new book or a used book? Doesn't matter. You know how
Yeah, you can. Yeah, you don't want to buy them used somewhere. You know what it is, right? Looks like this.
Okay. And we don't need that little card to work online. You know how with the so many times.
I think I know what you're talking about, but I don't.
We hand in everything on paper.
I don't really care if you hand if you hand it on paper or if you send it to me. Is that what you're thinking?
Well, so many times we don't work with the teacher. You do it online.
Oh, okay. I don't really. I'm trying to think. I know what you're talking about, but that's like an online course.
Yes.
So.
Okay, so
Yeah.
you don't have to worry, so we can get a used book.
Yeah, you can get a used book. Okay. So let's see. Okay, so I just need your
I
geo
have the
number.
money, so you might not be able to add me because of that too.
You don't have a geo. Oh yeah,
Oh,
you
yes, I do.
Right there.
Yeah. I'm on hold, so I gotta go in to talk to them too. Okay, okay.
Okay, so it says the registration overrides have been entered. You advise the student that he or she must register now. So if you do hold through my PCC, you can register for this course.
Okay, okay.
You'll be all set.
Perfect, thank
All
you.
right, you're welcome.
And I have another question. That's my daughter there. We're kind of doing it together, but they scheduled her to work today, and she never works Saturday, so would it be all right if we left at 10?
Yeah, you can leave anytime you want. Okay.
It's just this one day.
Don't worry about it. Now, so everything's so at about 10. We'll probably be just about done with 2-1 and 2-3. Okay, and then I want to stop, and that's when we do our assignment stuff. But I'll have this recorded and saved. Okay, so we're going to continue on here, go on to 2.1, which is about solving, these are linear equations. All right, so solving an equation, there's 3 ways to do that. All right, one way is sometimes known as like a paper and a pencil sort of way. All right, some people would know that as being algebraic way, although all the other techniques are also algebraic. The textbook uses symbolic, which I guess, or what do they say, symbolically.
Is 2.1 or 1.1?
This is 2.1. Yeah, we're all done with chapter 1. Yeah, how about that, huh? Finish that off in a hurry. Okay, so that's one way. The second way is graphically. And the third way is numerically. I'm just going to put a table next to that. All right, so some equations that you solve in mathematics can only be solved graphically. All right, some are much easier to solve paper, pencil, algebraic, symbolically. I imagine if I put something up there, probably every single one of you would do it that way. All right, because that's the way you're used to, and you're comfortable with that. So that's what you're going to do. All right. Maybe some of you might say, might try it graphically. I don't know. It depends on how comfortable you are with that. I doubt anybody's going to do it numerically. However, all right, when I talk about this technique in high school, I relate it to the old strategy of guess and check, because it's sort of familiar to that, or similar to that, guess and check. All right, and years ago, well, I guess they used to teach that kind of stuff like in the lower grades. Here's an equation. How do you figure it? Well, just guess and check. And I guess you kind of guess and check your way through life sometimes, right? I think I'll do this and see what happens. All right. So it's a pretty good. That's the strategy behind it. But numerically and tably is kind of related to that. So I'm going to show you all three things. All right. We're going to use Desmos again for graphically and numerically. Are you any of you all have smartphones and stuff, so you're able to access it or not? Okay. So and by the way, so you can use anything that we use as a tool in this class. You're going to be able to use on your test. Okay. So it's a weird thing. PCC wants you to use Desmos, but yet they have these rules against using phones. Basically saying you're going to cheat and look things up on tests and stuff. But if you write I guess if you write your test to where they kind of limit that availability for you, then you just got to be a little bit, make sure you do that. But anyway, so you'll be able to use it. All right. So if I show you how to use Desmos, it wouldn't be fair for me to say, oh, but now you can't use it and get your test. That makes sense. So it's a tool. So anyway, but you probably don't want to put that on social media that Patterson lets people use cell phones on their PCC math test, because then somebody's going to say, what are you doing? All right. So don't do that. But anyway, let's do this. So we're going to start off with a simple equation here. 3x plus 8 equals, and this is, you did this in some of your previous math courses, whatever it was that you did. Okay, -3. Most of the time when I'm making these problems, they never come out to be nice numbers. All right, so don't. In the book they do, because they spend hours trying to make sure they come out with right numbers. And I don't spend hours trying to make sure these come out with right numbers, because very few things in life do anyway. So we're going to solve this equation. And again, if I asked you to do it, you'd probably, just going to work it out. So what would we do first? Obviously, what are we going to do? Yeah, -8, right? You've probably done a bunch of these, so Okay, see, here we go. All right, all I would have had to do is make that a 4, and we would have had a nice number, but oh no. I do it like this, okay? And so this would be our exact answer. And then if I made it into a decimal, this would be my approximate answer. All right. So what's the difference? Well, 11/3 gives us a precise and exact answer of what it is. And even though it's 3.6 repeating, at some point you're going to stop and you're not going to write 6s anymore, and that's just going to be an approximate answer. Okay. So I don't really care which one you give when you're doing stuff like this. It's completely up to you. If I want an exact answer, say, give me an exact answer. All right? Otherwise, I don't really care. I'm more interested in the fact that you can get an answer and that your procedure is correct. Okay? That's what I'm big on, is making sure your procedure is correct. So this is done. Oh, that was easy. All right. If we want to do it graphically, then obviously we're going to make a graph. So I'm going to unplug this guy. All right. Nice and easy. Hope I don't wreck my little thing doing this. Okay. And so we'll go back to this. Back to my buddy Desmos here. All right. I'm going to type in y equals 3x plus 8. Like that. Okay. Then below that, I'm going to type in y equals negative 3. So 3x plus 8 was on the left side of the equal sign, and y equals negative 3 is on the right side of the equal sign. All right. I don't know why I'm getting this thing here, because I wanted negative 3 and it thinks it's a slider, and I don't know why it does that. I've never seen that before. Okay, so here is my answer then, is where the yellow line, or orange, whatever you want to call it, and blue cross. So when I type those in, right, all I got to do is tap right where they cross, and there's my answer, negative 3.667. Is that approximate or exact? It's approximate, right? Okay. So Desmos is always going to give you an approximate answer. It's never going to give you an exact answer unless it's a nice number like 2 or something like that. Okay, so it's always going to give you some sort of an approximate answer. That's the downfall if we need an exact answer. Right? Numerically, I can show you how to do it numerically on here. All right, I think most of the time they're going to give you the table. There are some times where they're going to say solve it numerically. All right, so let's solve it numerically. So I'm in Desmos. I'm going to go to the plus here, and I'm going to add a table. All right, so now I have a table. Okay, so it helps to know that I know what the answer is. So I'm going to go negative 4, negative 3, negative 2, negative 1, oops, 0, 1, 2, 3. So I'm just typing these numbers in, right? Okay, negative 4, and I'm using the keyboard, but be sure you use this guy. I use this often. All right. So I got those in. There's my numbers. Over here, right up here where there's a little purple with the Y1, I'm going to click on that, and then I'm going to delete, not to the, I'm going to leave it, it's going to get rid of the Y, and the purple is going to go away, and there's going to be a triangle there, which means, uh-oh, something's wrong. So now what I'm going to do is I'm just going to type in the equation, but here's how you have to do it. So we're going to go 3x1 because this is x1. So what we're doing is we're telling it to take, hey, could you take these numbers, put it into this formula, and tell me what the values are. So I'm going to go 3x1 plus 8. All right, so now it's made a table. All right, and we'll put the points on there. That's really nice. Okay, so, but I'm looking for negative 3. Well, this is negative 4, and this is negative 1, and all these are positive. So unless this thing's going to do something crazy and come back up or something, my answer is going to be between these two. All right? Because that's where negative 3 is. Okay, so man, I don't really need negative 3 here. I need to make this like negative 3 point, maybe I'll go 8, and then maybe I'll make this one negative 3.6, and maybe I'll make this one negative 3.4, and maybe I'll make this one negative 3.2, and I already know what negative 3 is. So now I'm looking for, I'm looking for negative 3, and see here, again, I can tell that it's between these two, right? So it's between 8 and 6, all right? So then maybe I'd make this one, I'm going to make this 7. So I'm going to delete it and make this a 7, okay? And then make this one, delete it and make it a 6. And again, I can see, oh, now it's between 3. So you're thinking, man, really? This is a lot of work. 4. So this would be 8, and I can make this one negative 3.78, and then negative 3. Oops. Well, actually, it was between, I think I'm going the wrong way here. I think it was between 7 and 6. I got 2 negatives there or something like that. Okay, so it's between there, so I'd probably make this maybe an 8, and then make this one a negative 3.66, and so forth. Alright? So you can see that, oh, now it's between there. So I mean, you could do, again, you could do this for a long time. Alright? So the downfall of this is that it takes a while to do it with a table. Okay? Because you got to keep playing with it till you get it. It's just not as convenient as wrapping it. Alright? It doesn't give you an exact answer because it would take you a long, long time to get an exact answer. So when you're using a table, alright, most of the time they're going to give you the table, and if they don't, then if you can get down to tenths or just an approximation, you know, I'll be happy with that. Again, I'm more concerned that you can make a table and come up with an answer than, you know, getting it so precise and spending a lot of time messing around with that. Alright. So as long as you can get a table, that's great. Alright, and you know what to look for. Okay. So numerically takes a long time. There are some equations that sometimes you gotta solve them by using a table. Alright, hopefully you have something that's going to generate the table for you, and it doesn't take you very long to get it. Alright, and you can kind of see what it's doing down here. It's just getting really, really close to that number. So those are the 3 methods. Alright, so let's try some more here. And numerically the table. So we made a table there, x, y, and let's see, -3.7, 3.6, and -3 was sort of in there somewhere. Alright? Okay, so let's do another one. Let's amp it up a little bit. 3, -2 plus 1 equals 4 minus 3x plus 8. So we have something like this. I have no idea how this is going to turn out. Alright. So here's my equation. I got x's on both sides. Alright. I'm ready to solve this out. So now I would go ahead and do this algebraically or symbolically, paper and pencil. Right? So we're going to move that inside. This is going to go here. It's going to go here. I can actually make this a 12. I think I'll move this over here. You guys can solve it out too. You've probably already beaten me. 3, 12, 3x. And oh my gosh, this one worked out. Okay, so that would be the symbolic way, right? So now, all right, if we wanted to solve it graphically, then again, what we're going to do is split this up. So we put this in one side, and we put this in the other side. Okay, so let's just try it out. Go into Desmos, so I don't have to unplug it all the time. Go in there, graph it, and see if you come up with -3, right? So go put this in one part and this in the other part. Okay, do that. See what you come up with. I bet you get -3. Nothing's going to let me do it. Oh my goodness. I don't want to register these. Here we go. What is this asking me for? Good. Did you get it? Yeah? Sweet. That's one person said yeah. For a table on these, it's a little bit tougher to do. Get rid of this, get rid of this, get rid of this. But you can do it. So what was it? See, the answer was -3, so -4, -3, -2. I'm not going to do a lot because we obviously know what the answer is. So you would come up here again and click and delete. All right, and then we would type in the first equation, 3 parentheses -2x plus 1. Oops, I got to put x1 there. There we go. And then I think you can come over here and you would put in the next one. So 4 minus 3x1. You always got to put x1 in there, or x2, whatever it comes up, plus 8. All right. So in this case, so I put the left side here, the right side here, all right, and I just put both numbers in there. Since these two equations are set equal, it should make sense to you that, oh, hey, there's this number, that's the answer, because they're both 0.1, all right, and that's the deal there, okay? So you can solve those ones numerically too, all right? It's just you got to make two. You got to make a second column, one for the left side, one for the right side, all right? So you can use Desmos to solve these graphically. You can use them to solve it numerically. I'm not gonna, I think probably because it's a kind of a challenge to do them numerically, I'm not going to have you do a lot of problems like on a test or a quiz on that kind of thing. All right, so it'd probably just be basically, to be honest, what I would do is have you solve an equation, all right, symbolically, or paper, pencil, well, that's the right way I would call it. Verify your answer with a graph, okay? And that to me is big because, and I mentioned this when I was teaching 65 last term, if you can do it and then check your answer with a graph, and you know that your answer is wrong, that you worked out, on paper and pencil, all right? Because the graph says it's 4, and you got 2. Something must be wrong. And you go back through and you check, and you can't see your mistake, all right? And you know you graphed it correctly, because that's a possibility too, but highly unlikely. And if you tell me, hey, I know I made a mistake, but I'm not sure where it is, that's great. I like that, because that means you're telling me that you understand that there's a mistake there, okay? And it might just been something small. So, if that comes up and that arises, make sure you do. But the nice thing about it is you can graph these things, which doesn't take very long, and you can get it and check your answer. You need the back of the book. Who needs it? You can just use Desmos to graph stuff, because it really doesn't take very long. All right. You're going to get a chance to work with some of these too, so if you're not sure how to do something. There are cases where you could have no solutions. I just don't think there's any of those in here. No, I don't see where it talks about that. I don't know if there's any problems like that on in here. Maybe we should just do one, just so I feel like I covered that. So if we have something like this, and we work this out, oops, what was I thinking there? We'll simply make this into an 8, there we go. Bless you. So I'm zipping along on here, oops. And I notice that the x's are canceling out, and I get negative 15 equals negative 1. All right, so I know that this is not true at all, so this would have a no solution. Okay, so if my x's cancel out, then I'm either going to get no solution, because I get negative 15 equals negative 1, which is a false statement, or quite possibly I could get a whole bunch of numbers, meaning all real numbers, if this statement down here is true. So if it was negative 3 equals negative 3, then you'd say it was true. If you solve that graphically, and there was no solution, and I put this equation in and this equation in, and I graphed it and I got 2 lines, what would those lines have to be? There's no solution. Not perpendicular, close. Parallel. Okay? They got to be parallel. Because we're looking for where they're going to cross. And if they don't cross, they're parallel. All right? Good. Questions on 2.1? That's that one. You'll be happy because they skipped it, and they do all the skip the word problems, so you'll be happy with that. Don't have you do those. Anything on 2.1? Solving equations, you've done it before, so. Okay, we're getting through it here. Alright, one more, then I'm going to let you do some problems on your own here, give you some homework time here. So, linear inequalities. And this isn't anything new either, you've done this before. All right, so an inequality looks like this guy, this guy, these. All right, and so we're going to solve these. And again, it's the same thing. You can solve them using a graph. You can solve them paper and pencil. You can solve them numerically. All right, you can still solve these all the same way. All right, so if we just pick one out, like that. I'm even going to make this one work. Okay, so here's my deal right here. I got greater than. Okay, I solve it like a regular equation. Nothing changes. There it is. X is greater than 1. All right. Now, here's where it tricks people up. So that's one way to write the answer. All right. Another way to write the answer is to use a number line graph. So I'm going to put an open circle around this, and X is greater than 1, so I'm going to go this way. All right. So if I have a greater than or less than, that's going to be an open circle because it does not contain that particular number. If I put this guy, this one, then that's a closed circle because it does contain those. But this is just a greater than, so I have an open circle and I have all those numbers. The nice thing too is if you write the X first, this will point to where you're going to graph. So since this is pointing that way, then I know I'm going to go that way. But you have to write X first. Okay? If you don't, then it doesn't work that way. So this is with a graph. And the other one is called interval notation, which I'm pretty sure you did. And if you haven't, interval notation goes like this with a parentheses if it's this way. Oops. Put that around. Brackets for that. Alright, so in this case, I would solve the equation. First of all, I'm going to start with a parenthesis because I have this as my sign. So I'll go parentheses 1. Alright. And then since that graph goes to 1, it goes on forever, we put infinity parentheses. Infinity always has a parenthesis. So this is called interval notation. And they will tell you that they want you to write the answer using an inequality or interval notation. I'm sure I saw that on here. Alright, so that's what that is. Alright, that's interval notation. This is just an inequality. You don't have to write it as a graph. I don't think there's hardly any number line graph things you have to do, which is pretty good because you've probably done a bunch of those. You don't need to do them. However, when we do some of the other things later on today, you'll see where we'll use a number line graph and it's actually going to help us. Okay, so that's how I would solve that, paper and pencil wise. Let's just do one more and then I'll show you how to do it with a in a graph. Let's do one like this. I have no idea how it's going to turn out. Here we go. So, here's our problem. So we're going to distribute this inside. Okay, so I'm just going to add this over here. Normally I probably wouldn't, but I'm going to illustrate something here. Add the 20. Add the 20. That's not too bad. Divide by 10. When you divide or multiply an inequality by a negative, we got to flip the sign. Yep, you're right. So we got to take this sign and we got to flip it. Okay.
Would that be 14 over negative 10?
Oh yeah, thanks. So interval notation, let's see, this time, so we have x is less than negative 1.4, so it's coming back this way towards me, towards this way, right? So then I would start off with, well, here, let me just show it to you. So this would be negative 2, negative 1. Okay, so we're going to go this way, all right? So this is negative infinity, so we go negative infinity, all right? Negative 1.4 bracket, because that's going to be equal to it, all right? So we would put a bracket there. Okay. But many times they're going to just say this is an okay answer, all right? But they might ask you to put some in interval notation, so I want to make sure I got that. And the interval notation tends to flip people up a little bit. It's a little bit harder to write them that way, but it's, you know, kind of convenient. Okay, so using Desmos to solve something like this. All right. Yeah.
I have a question. Are we going to be using set notation at all?
That's kind of the same, right? Oh, are you thinking?
It's the one with the curly braces.
Yeah. I don't think they're going to ask you for that.
Alright.
They might. They will in the domain thing, but I'll show you how to do it when we get to that part. Okay. Alright, so we got this guy here, right? Oh, graphically, yeah, here we go. So let me go back, put this last one in here. Y equals negative 4. I'm going to start using this a little bit more. Negative 4, parentheses, 3x plus 5. Here, I'm going to put that in there. Y equals negative 2x minus 6. Put that right there. Okay. So there's my point at which they meet, right? That negative 1.4 is important. Now, I'm going to have to come up here and write this. So we have negative 4, 3x plus 5. Which way do I have it? Do I have it this way or this way? Start off that way. Okay. 2x minus 6. So we want this equation to be greater than this one. Alright? So let's see, this equation is red. So I want the red equation to be greater, okay, than this one here. Alright? So did I do something not right? Yeah, but it shouldn't matter in this case when you do it graphically, because you want this to be greater than this, and for some reason yeah. Oh yeah, it's just it's so slight because of the slope. I see it now. Yeah, so this red, this is not a very good example, I guess. So this red one is above the black one because it's, so this one is going up higher than this guy is. So that makes the red one above for anything that's over this side of this number. So if this was tilted just a little bit more, you'd see it better because it's larger, okay, because it's going up higher than the black one is. Anything this way. Otherwise, it's down here, so it's less than that. Let's see if we can find a better example. That one probably doesn't work out very well graphically. Maybe if we play around with this and make it look a little bit more. So there would be a -7, 8. And we want the black one. This time, the red one is still, we want it to be greater. So that might change it though, so it's a different way. So here, all right, since this equation is, for some reason this graphically one is just kind of throwing me here. It's not looking right. But there's one in the books that are actually better than this. These are, if you look on page 117, let's do that instead, because these ones are better. All right. If you have your book, if you want to look at 117, number 63 says y1 is less than y2, and that's going to happen when y1 is less than y2. So they cross at about 1, right? Is everybody seeing that? They cross at about 1. Okay, but y1 is less than y2 for all numbers that are greater than the number 1. So we would say the answer to that is all numbers greater than 1 or equal to it. Okay, because the blue one is less than the red one is after number 1 on the x-axis. Before it, the blue one is higher than the red one. Okay, so in my case, it's kind of hard to tell because of the way these are. You know, if I had one slanting the opposite way, if I really messed with this, now it'd be much easier for me to figure out what's going on. Okay, so here at -2.429 is where they're equal. If we want to be greater for the red one, then we would pick here. But if we want it to be less, then we would pick all the numbers on this side of it. So that's how you do it graphically. All right. Graphically solving these is a little harder, obviously, than it is when they're just setting them equal, because you got to kind of dissimulate it out. But that's how they would do that. Okay. So 64, same thing. Y2 is a nice horizontal line. Y1's a blue line going diagonal. We want to know when y2 is greater than y1. Well, they meet at 2, but y2 is greater for all numbers that are less than 2 because it's above the blue line. But for numbers that are greater than 2, it's below the blue line. Okay, so it would be everything that's to the less of 2. So there's only a couple of those that you have to worry about. And they really don't do anything with tables. They do a little bit, but they just have you complete it. They stick domains of functions in there. Let's see, did I give you any of those? 45 through 49, yes I did. And they want you to use that set builder notation again I was talking about, so let's do that real quick here. I'll show you what that looks like. So if we have a function here, f of x, you see they have a lot of stuff. And I graph this. Let's do this one. this graph. -1, and it's going to go like this. Okay. So it wants me to say what the domain is. Okay, so the domain. All right. And using what they call the set builder notation. So you would put down brackets like this, okay, and X, because it's just domain. Come on. X, colon means such that, all right, X is greater than or equal to -1, like that. I think they just want you to do that because of the inequality. They're trying to show you an application of it. It's kind of hokey, but it's there. All right. But again, there's not too many of those either. There's just a few of them. And all of them are going to have some sort of a restriction on their domain. Okay, so that's 1, 1, 2, 1, 2, 3. So let's take, I usually take like about an hour or so. All right, so here's what's going to happen. So I'm going to give you about an hour. You can take a break too if you want at any time. Work on some of these problems. All right, and I would suggest, I know some people are just going to do like one section, just go, that you do pick some other ones out of 1490 and 116, just so that you kind of know what's going on. All right, and then maybe you can organize it, I don't know, together. It's up to you how you want to do it. And then if you have questions, we'll go over any of that. Then we're going to do 2.4, and then we're done. Okay, so, we should be done by noon, I think, if you need to know that. All right, because it'd be about an hour, it'd be 11, a few questions. Yeah, we'll easily be done by noon, I believe. We don't have anything else to do, so. So take this time, work on your stuff, and then I'm trying to remember. Let's do this. I think it was this. And so Hernan came up to me and showed me this, and I said, "This is a good idea." I said, "Okay." He showed me this. I don't remember what the other one was, but maybe it doesn't make a whole lot of difference. As long as we get a, where's the other? And then he did this. Oh, put a y equals in front of it. And then a y equals in front of this one. That's kind of what you did, right? Yeah. So here's your, here's your point here, -2.73, that solves the whole thing. But when you put this in, it shades it for you. So it kind of says that the answer is going to be to the left of this number, right? So instead of trying to read the graphs, all right, try to figure it out like I was trying to show you, this is kind of a cooler way. I like that he did it. I had to think about it for a minute. Yeah, I guess I see what it's doing there. So if it's the other way around, so if we switch this guy around, then it's going to shade on the other side. So it shows you the shade on what side it points, and then you would know that it's got to be less than 2.73. So that's pretty slick. You just put the whole thing in there, and then split it up so you can kind of see it better. So good job there. All right. Last thing then that we're going to do here today is section 2.4 on compound inequalities. And I activated the course too. Okay. So I got it all activated. I did that while you guys were working on your stuff, so we're ready to go. All right, so 2.4 compound inequalities, what the heck is that? Well, really, that's not any different than what we were doing before. It just tosses 2, so it looks kind of like this. All right, so it's kind of 2 inequalities. So there's one, and here's one. Okay, so they're kind of put together. It's called a compound inequality, like that. And if it's easier for you, you could split them up. All right, so if you say, man, I want to do it this way, I want to split them up, and then work both of them from there. You can do that, all right? So if you did, you just solve this out normally, nothing's really going to change from what we were doing before with the inequalities or what you've seen before. So there's that. There's that. Okay. The only thing you have to know is with this particular compound inequality, if I read this, it would be read like this. 2x plus 4 is greater than or equal to 3. And 2x plus 4 is less than or equal to 8. The and is the key word in there, because that tells you that 2x plus 4 has to satisfy both of those conditions, not just one of them. So it has to be greater than 3 and has to be less than 8. All right? Or, well, equal to it. But it has to be both of those conditions. So when we look at this, all right, from a graph standpoint, remember I said we were going to look at some and using a number line graph. So if this is on -1, 0, 1, 2, 3, 4. So here's -1/2 right here, and this is 2 right here. Okay, our answers are going to be, this x has got to be greater, so that would be that way. This x has got to be less, it's got to be that way. So it's an overlap of these two things, because it's an and, so we're looking for where they're going to overlap. So that means our answer would look like this. So this would be a graphical way of demonstrating it. This would be as an inequality, and using interval notation, it would look like this. Now we'd have a bracket because it's got an equal to there, and a bracket on the other side. So there's 3 ways to write the answer. Don't write it all 3 ways, because that's a waste of your time. All right, so I think they're going to ask you to write most of these in an interval notation. All right, so that's how you're probably going to write them. They might say, write it as, here's one that says, graph it on a number line. And here's some that say, write your answer in interval notation, interval notation. Pretty much all of it is going to be in interval notation. Okay? There's a couple of graphs. Now, but what we did here is, let's go back to this original one. I'm going to go back up here for a second, slide this over here. So here's what this looks like. And you don't have to break it up. Okay? You could just say, well, I'm going to subtract 4 from all 3 of these things. So -1, 2x, and 4. And then I'm going to divide everything by 2. So I get 1/2 x and 2. So you don't have to break it up. Okay? You can if it's easier for you, whatever is easiest for you is what I want you to do it as, however you understand it, but you don't have to break it up. You can just work it out in that form, right? So that's an example of an AND. We call that an AND problem because it has to satisfy both conditions. All right. Let's look at another same thing. So let's do another one here. So I'm going to go -4. This time we'll go like this. We'll go 5x minus 8 this way and this way. So we need to, all right, have negative or 5x minus 8 be greater than -4 and 5x minus 8 be less than 12. So it's got to satisfy both conditions. So again, I can either split it up or I can just do this. I think what I'm going to do this time is I'm just going to work this out. And I'm thinking that some of you are probably saying, yeah, I like this because it's a little less work. All right? So this would be 4. And this would be 20. And now I'm going to divide everything by 5. So I get 4/5 here and 4 there. So look, there it is. I mean, that's it. All right, I didn't have to split it up. I can just add 8, which is what I would do anyway. Divide by 5 is exactly what you would do if you did split it up. And now you got the answer. You just got to write an interval notation. So with the parentheses, and this time because we don't have the inclusion there, so we go like this, and that's your interval notation. So that is done. Okay, so again, that is an AND problem because it has to fit both of those conditions. All right. Now, let's change it up a little bit and take a look at a OR situation. All right, so in an OR situation, we would have 3 negative, let's go like this, 2x plus 1, or, oops, I want this to go the other way, or 2x plus 1 is greater than 8. Okay, so now, this is an OR problem because it tells you right here that it's an OR problem, which means that it has to be either less than -3 or greater than 8. So it can fit either situation. This one's already split up, so I think that's how I'm going to do it. Or divide by 2. So I get this, or I get this. Oops, 7/2. So in a graph, this looks like this. So I'm going to have 1, 2, 0. So I'll put -3, -2, -1, 0, 1, 2, 3, 4. 7/2 is 3.5, so it's going to be right there. Okay, so 7/2 right there, and I have an open circle because it's just a greater than. Remember I said if x comes first, then it's pointing to where it's going. So this one's going this way. Here, x has got to be less than -2. Open circle. Less means it's going to go that way. And there is no overlap. But there's not going to be with an OR because it only has to satisfy one of these conditions. So it's here or here. All right? So an AND, we noticed, came together. So the ANDs are going to overlap. The ORs should not overlap. So that's an OR. So an interval notation, all right, here we would have negative infinity because it's out this way, negative infinity, parentheses, to negative 2, parentheses. I wonder if they... Okay, they use this, parentheses, 3.5 or 7/2, whatever you want to write there, to positive infinity. Now, this symbol, the old expression is older than the hills, okay? So, like, it's way old. This goes way back to unions and intersections of sets. That's what that means. It's union, so it means that it's both of those things. All right, but it's the same as or. So, you know, if you were to say on a test and you put an or there instead of a u, that's going to be fine with me. I mean, they're the same thing. The u is just a real older way or shorting way maybe of saying that. Okay, you don't see it a whole lot, but a little bit. So, there's your answer for that. But there's no overlap because it's an or problem. And it's easy to tell because it says or. Let's try another one here. So let's go with, and I'm doing some, the ones in here are a little bit easier, by the way, so I'm doing some of the hard ones. Looking for another or one. No, I'll just make one up right here. Or let's put a negative in front of these so that they have to switch some signs. No, I've already messed you up enough. Leave it like that. All right. Let's see. Then we want to go this way. 12. Okay, so here we go. All right. So we're going to subtract 5. Subtract 5. Negative 13, this way, 3x, same thing, subtract 5, 7, divide, 3, or okay, so if I graph these, right, negative 13 thirds less, so it's going to come back towards me. 7 thirds greater, it's going to go that way, so they're going to be split. Interval notation, we're going to write this as negative infinity to negative 13 thirds, right? The little U shape, parentheses, 7 thirds, except this should be a bracket here because it's equal to it. There we go, bracket. To positive infinity, parentheses. All right, so ors, they're going to tell you if it's an or problem. And they're going to be together, all right, like the first one that we did. They have a couple of ones in here where they have an and, all right, but I mean, they're pretty straightforward. Let me just do one for you. Let's see, what are ones that which ones do you have to do on here? Multiple of 3, so I'll do a multiple of 3. Here we go, 21. So like for example, 21 says 1 is greater than or equal to negative 2 and x is less than 5. And it says, write the inequality in interval notation. Oh, well, you already told me what it is. It's got to be greater than negative 2 and less than 5. So I'm going to go with bracket negative 2. Now it's an and, so they're going to come together, see? So here's negative 2 right there, 5 right here, open circle, open circle. Going this way. Greater than negative 2, solid circle going this way. Okay, so here's the overlap, right? So it's negative 2 to 5 with a parenthesis because it doesn't have an equal to there. All right, so there's nothing really to work out. You just got to write it in interval notation because it's telling you what it is. I'm going to have that for a number of them. I was giving you like harder ones. Let's see. Here's one. I know some people are going to say, what the heck do I do on this? So what if we have negative 2 greater than or equal to 3x minus 1 over 4 less than or equal to, let's throw a negative in there just in case, because we haven't done one like that, and we'll put a 6 over here. Alright, so let's say we have something like this, alright, where we got a fraction thing, okay? What I would do is multiply everything here by 4, because you want to get rid of this 4, alright? Hardly anybody likes fractions, so we're going to get rid of that 4. If it would be a 3, we'd multiply by 3. If it was 2, we'd multiply by 2. But it's 4, so we're going to multiply. Okay, so I'm going to get negative 8 less than or equal to. Now when I multiply by 4 to this 4, they cancel. Right? So they're gone. So I don't have to worry about it. So then I have negative 3x minus 1 less than or equal to 24. Okay, now I just work it out like I would before. This is an and problem. I'm going to go like this. I'm going to divide by negative 3. But when I divide by negative, I got to switch this sign here. We got to switch it. Switch this one. But it still works out okay. It looks really odd because we're not used to that. Again, it takes kind of out of a little bit of comfort zone there. But this guy is the same as this if we rewrite it so it looks a little bit more like what we're used to. Okay, and you say, well, how in the heck can you do that? Well, I'm saying the same thing. X is less than 7/3, but greater than negative 25/3. X is greater than negative 25/3, but less than 7/3. So it's said the same way. This is actually more proper mathematically. All right, so if we did this in an interval notation, bracket, negative 25/3, 7/3, bracket. Okay. Whew. So there's that one. That takes us up to about 8. Then they say use a table to solve the 3-part inequality. Did I give you any of those? Let's see. 81. Yeah. Okay. So if you have a book, you might want to look at page 129. All right, because it's easier for me to just show you one in the book than it is to derive one on decimals. All right, so like for example, 81 says negative 3x is greater than or equal to negative 3 less than or equal to 6. So the table looks like this. Okay, this is 81, page 129. Here's the problem. All right, and then the table goes negative 2, negative 1 down to negative 4. Negative 2, negative 1, 0, 1, 2, 3, and 4. There's your x's. And then the y has negative 6, negative 3, 0, 3, 6, 9, and 12. And it says, so we want to solve it between negative 3 and 6. So well, here's negative 3 right there. Okay, so that would be this number. And 6 is here. That would be that number. So it's got to be between there because it's an and. See, because this is an and. So it's going to be between these numbers. There's the ones that are going to work. So in interval notation, I would write bracket, negative 1, bracket with the 2. Because it's got to be between these numbers. It's an and problem. Everything in there is good. Everything outside there is not good. It's not going to work. So that's a table. So you just kind of got to look at it and find the answers. All right. But they're going to be nice numbers. They're not going to have decimals like that first one we did. All right. These are going to be, they spend hours making sure you get right answers. Okay. So there's a couple of those. There's a couple of these. They give you a graph. Let me show you one with a graph here. This is f of x, I think they call it. And no, they call it y. This would be y1. And then we'd have a line going across this way, and a line going across this way. So let's say 2, 3, 4. So I'm going to say this is 4. I'm going to say this is negative 2. So it says, all right, solve the inequality. It says use a graph to solve the compound inequality. Answer in interval notation. So it goes like this. So it says 4 less than, oops, I should start with negative 2. Negative 2 like this, y1 like this, and 4. Okay? So this is what it gives you. You got this, and you got a graph. And now you have to find the answer. Well, again, this is an and problem. Okay? So it's got to be between. So here's 4, here's negative 2. So it's going to be all these numbers in between here. But we have to find those by going down, all right, on our x-axis. Let me change this to like a blue or something. Going down to the x-axis right here and figuring out what that is, and then our x-axis right here and figuring out what this is. Okay, so let's say this is negative 1 because it kind of looks like it is. 1, 2, 3, 4, 5. 5. All right, because I'm solving for x, so I have to go down to the x-axis with the green, right where it crosses, right there and there. So interval notation, it's these guys, so I don't use brackets, negative 1 to 5, like that. Okay, so on these graphs, it gives you the dividing lines. All right, here's what you're trying to keep it between these two. So it's between these two when we're from here to here. Here's my green, this is y, is the green. All right, so it hits there, so I go up, hits here, so I go down, there's my x's. So it's got to be between those two. And that's the and.
Which one was that one?
I made this one up.
Oh.
If, let's see, we have another one. Come on, pen, don't give up on me now here. There we go. See if I can get rid of this thing here. Pen is not working. Of course not. There we go. Good. All right. So here is an axis here. All right. So let's draw another of this. There's my function y. All right. And then I'm going to draw this here and this here. So we'll say this is 1, 2, 3, 4. Negative 1, negative 2, negative 3. And this time, we want negative 3, we want y to be less, or we want y to be greater than 4. So this is an or problem. All right. So I'm interested in here, and here. I want to know what that is on the x-axis, so I'm going to drop that down. Drop that down to here. 1, 2, 3, 4, 5, 6, we'll call it. Drop this onto here. 1, 2, that's be -2. Okay, so there's my point. Okay, but it's an OR problem now, so it's not the stuff that's between these two. Alright, it's outside of them, because we want y to be greater than 4, which is out that way. And we want y to be less than 3, which is down this way. So these ones are going away. So it's a classic OR problem. It tells you that's an OR problem. So our answer is going to be parentheses, negative infinity, -3, parentheses, or you can use a u, whatever you want, 4 to positive infinity. Alright? So that's another graphical way of looking at these. Now you don't have very many of those either. There are a few of them. Alright? Most of them are just going to be grinding them out, paper and pencil, symbolic, whatever you want to call it, to get an answer. Okay? So, little different stuff. Ands and ors is the big thing, right? And the interval notation is kind of hard. Do you want me to do a couple more, or what would you like? -2 and 6, yeah. It's hard to see, huh? -2 and 6. Oh yeah, what did I put down there? 3 and 4, what a dummy. Thanks for pointing that out. So this would be -2 and 6. Yep, thanks. That's what I meant to put in there, not 3 and 4. Because those are on the x. Yeah. Alright, so that's all I got. If you have any questions on anything, you know, I'm more than happy to stick around as long as you want. Otherwise, that's about it. If you have any questions during the week, email me. I'll get back to you as soon as I can. If you need pictures of the book, grab it. It's here for you.